Hello everyone. My name is Valentina Chacon, and my project is called Rogue One, a legitimacy story, and I did it under the guidance of Professor Nicolas Cardoso. Um, so the main thing here was that the increasing changes in the interaction and activities available online increase the privacy concerns regarding online presence. And so the way by which web pages are able to solve this is by providing privacy policies. But these policies have many problems. They can be really long. They're even like 8 pages long, and they can have vocabulary that is not understandable by everyone. Another deal is that we figured out that an average person can take about 200 hours a year to actually read every single policy. And this presents a lot of risks because when a user enters a page ignoring the privacy policy, the user is exposing himself to risk regarding the handling of their data and the legitimacy of the service offered by websites. So in order to solve this, what we want to do with this project is create a model that's able to determine the legitimacy of a web page, meaning that it can determine whether it's legit or rogue based on the contents of its privacy policy. So to solve this, this is the workflow that we had. First, we start with a data set. We have legit policies and rogue policies, and we do some pre-processing. We remove all lowercase letters. We have no special characters, no numbers, no stop words, and we lemmatized all of the words. And the second step that we did was trying to translate this natural language into something that was understandable for a computer. So in order to do that, we use the back of words representation. And there's like a short example of what we could do in here. We would grab two documents, create a dictionary, and from this dictionary, now we're able to represent our documents as vectors. Because we did everything in Python, we use the TF-IDF vectorizer that comes with the scikit-learn libraries. Once we have our words available to training, we go into this part in which we use different algorithms. We used 4 classifiers, which were random forest, stochastic gradient descent. From now on, we're going to refer to it as SGD, k-neighbors, and the Gaussian process. And our validation, because of the nature of the data that we had, because we have so many, like so few samples, we used 10-fold cross-validation because we were not able to create a validation, a training, and a testing set. So instead, we did the 10-fold cross-validation. So this is a general overview of the experimental design that we had. There were 2 main stages. Stage 1, we focused on the data representation, meaning that we would change the parameters of the vectorizer. And on stage 2, we focused on the classifier. So for experiment 1, what we wanted to figure out was how each individual parameter interacts in the vectorizer. So we just changed the values for one parameter at a time and left the other ones at the default. As you can see here, I'm repeating min_df twice and max_df twice, and this is because we have 2 variants, and this is really important. We have a way in which we can try this parameter with an integer value, meaning that we would like to exclude those values that appear in less than 5 documents, or we can use a decimal value telling us that we want to exclude those documents that appear in less than 10%, let's say that. And with max_df, we have the same 2 variants representing either complete documents or percentages. For the classifiers, I told you before, the focus here is not the classifier, so we left it with a default, and we tried it out with the 4 different classifiers. Later on, for experiment 2, we now wanted to see how each parameter interacted with each other, and so we created different combinations, but this time what we had in mind was always respecting data types, meaning that we would only combine min_df of integers with max_df of integers, and we would do the same with decimals. This time, because we had now many combinations to take into account, we only tried the top 2 classifiers that had the best performances in the previous stage. And finally, for experiment 3, what we did was not only focus here in the vectorizer, we also try to enhance the results by changing the parameters of our classifier, which was the best one was SGD. So now I'm going to show you the results that we got. This is experiment 1. As I told you, we were only tweaking 1 parameter at a time. And through this, we were able to understand that the top 2 performing classifiers were SGD and k-neighbors. The top accuracy that we got was 89.5. And an important thing to notice here is that there is not a clear trend whether having more values for max features or less values is better. We don't know that yet. When we move on to the second parameter that we were trying, which was min_df, we can see that regardless of whether we're using integer values or decimal values, we can see a trend in both of them. And what we see is that having greater values for mean DF is actually decreasing the accuracy for our models. The top accuracy that we got was 89.5, and for the decimal was 87.6. So it's important to notice that although we're trying out the same parameter, having integer values gives a better result. The last parameter that we tried out here was max DF. And again, we can see a trend in both of them, although it's a little bit different in integer than it is in decimal. But overall, what we notice is that having a greater value of max DF is actually better for the accuracy, meaning that we can enhance our performance by increasing this value. Overall, we got a quite good accuracy of 90.7% for the integers. And for the decimals, we got 88.9. And again, we conclude that having integers is better than decimals. Now we're gonna move into experiment 2, but before showing you the results, I want to make sure we all understand what these graphs are doing. So I know many of you have worked with them, but if you haven't, fear not. I'm gonna explain you real quick what they do. So this is a scatter plot, and what we want to do is show more dimensions than just 2 dimensions. So in the y-axis, we have the accuracy, and in the x-axis, we're gonna have the parameter that we're gonna try on. In this case, we have max features. We're gonna use visual cues, such as the color, to determine the classifier, and we're gonna use size in order to compare this parameter with another parameter. So in this first scatter plot that you see here, we're comparing max features, and with the size, we're able to determine what was the mean DF that actually gave us that accuracy. So for example, what we can see here is that the top accuracy was with 2,000 samples. And we can, when we did that with a low mean DF and a medium size max DF, according to these sizes that we have here. The top accuracy for experiment 2 was 91.3%. And when we go into the variant B on decimals, we can see the same trend. Having a min DF, a really small mean DF works best for the accuracy, and having a medium-sized max DF works best. Another thing that we took out from these graphs is that effectively max features, we don't have to have a specific value, because as you can see with integers, the best one was with 2,000 samples, and the best one with decimals was 5,000. Later on, what we want to do here is once again compare the interaction between mean DF and max DF and how they interacted with each other. And we can again see that having a medium size max DF and a medium and a small mean DF works best. This is clear in both our graphs. And finally, what we wanted to see in this experiment was the feasible results that we got, because in reality, there were many combinations of parameters that gave us an accuracy of 0, which we can see in this distribution over here. And so the insight we take out of these graphs is that if we want to enhance our probabilities of having an accurate result, meaning that we have an accuracy better than 0, we should stick to values, in the case of decimals, values less than 70 for mean DF. And we should stick to values greater than 70 for max DF. And when we're trying out our decimal parameters, we should focus on having a mean DF less than 0.5 so that we have better results. And we should also focus in max DF for values greater than 0.5. And finally, this is our third experiment. As I told you, in experiment 3, we did the same as in experiment 2, but this time we wanted to enhance the results by changing the parameters of our classifier. So this is a classifier we did SGD. And what we can see here is that in both cases, whether we're working with integers or decimals, the best loss that we can have is the log loss. The penalty is elastic net, and an alpha needs to be the smallest one possible. In the case of integers, we got a really good result, which was 93.2%. And we got this by having these characteristics of the classifier. And for the vectorizer, we had max features 200, mean DF of 10, and max DF of 70, which again tells us that it's better to have a small mean DF and a medium-sized max DF. And for decimals, we were able to get a fairly high accuracy, although it was not as high as with the integers. We got 92.6%. And finally, what we want to say is that, yes, it is possible to create a model that can classify the legitimacy of a website based on of its privacy policy, and we did that with a 93.2%. And when we compare this with the state of the art, our best model has a 3.5 performance improvement, which from our opinion is a really good result. And finally, for the future work, what we would like to do is try out our project with more data samples, as well as trying different validation techniques to compare the results. And we would also like to try other different machine learning models to see how the performance changes from one to the other. And most importantly, what we want to do is to make this usable for people, meaning that we want to develop a web tool or a plugin that's accessible to different set of browsers, and therefore people will be able to identify the legitimacy of the website visited. So I appreciate you listening to me, and I'm open to any questions that you might have.
Muchas gracias, Valentina. Entonces tenemos tiempo para preguntas. Jorge, ¿tiene una pregunta? Sí.
Questions can be in English as well.
Si quieres, sí.
So, Valentina, thanks for your presentations. Well, the question that I'm asking everybody, in your case, how do you determine if a website is legitimate or not?
Okay, so yeah, in reality, we got a data set that was already pre-built. So it already had the legit and rogue policies classified. But we did some research, and what we figured out is that they follow these policy guidelines that was created by the US, the European Commission, and Canada. And it's called the FTC Commission. And what they did was classify what's legit and what's not. And so that's how the data set is determined.
Okay. Can you remind me which were the methods that work best in your case?
Sure. So like this is the final results that we got. So in our case, what worked best was using a classifier of SGD. And the parameters that we used for that classifier was having a log loss, a penalty of elastic net, and the smallest alpha possible. And for the vectorizer, we had max features of 200, a mean DF of 10, and a max DF of 70. Like these were the parameters that gave the best results.
Okay. Do you have a rationale on why that was the method that worked best in this case?
Yeah, well, when we were comparing the different classifiers, we figured that in the end, SGD was, of course, the best because SGD has some vector machines behind all of it. So, of course, it is more fitted to the data that we had available. And as for the classifiers, as for the parameters of the classifier, we noticed that the default one is Hinge, but the best one for us was Log because of the sparsity of our data. So we read that having Hinge works best when data is not changing that much, but because of the variability that we had, Log was in fact the best one.
Okay, thanks, Valentina. Great.